Okay, we're going to move on to the very brief presentations, feedbacks on where we are with two working groups this morning. First of all, I'm going to introduce Michael Willford from Arup Associates in London. In fact, I'm just going to introduce Michael Willford from Arup Associates in London, and he'll tell you what he's been doing in the first working group. Maybe we could just welcome Michael. Pleasure to be here. And it's also a pleasure to be involved in this initiative on the seismic design of high-rise buildings. It is a matter which has concerned me for some time, and I'm very pleased to have the legitimacy, if you like, of the Council for Buildings to actually pursue something here with my colleagues on this task, Klemencic and Whittaker. If you look around the world, very different approaches in use. What we're trying to achieve in terms of objectives doesn't seem to be the same necessarily. We know we have seen inappropriate codes being used in inappropriate ways. And safety, frankly, is not always being assured by following these codes. The whole process is in a state of flux. There is what I call the old school, which is the UBC-style code approach, and this has many derivatives around the world. Many people follow the UBC, and they issue their national code based on updates of the UBC or IBC. And there's a new school which is performance-based, and I advocate that, as you will see as we go through. And really, this inconsistency is frankly unsatisfactory. I mean, we ought to have an international view as to what we're trying to achieve in terms of seismic safety. And so there is our initiative here at the Council for Buildings, but also you'll see that the engineers and authorities in Los Angeles, San Francisco are each separately trying to come up with new sets of procedures for high-rise buildings, because they are recognising that what traditionally has been done is unsatisfactory. And then I learned the other day that Pacific Earthquake Engineering Research Group, based at Berkeley, has got a $1.2 million research program into this, and they're going to produce something in a couple of years' time. We, David, I think have got zero budget, isn't it? And we're going to produce something, hopefully in draft form, at the turn of the year. So if we look at what the differences are between the two schools, the old school only allows you to use certain structural systems. It prescribes minimum lateral forces, and it's got rules for everything. You know, you have to do this, you have to do that. It's a single level check based around a 500-year return period. And actually, when you finish the design, you don't actually have to show that it will perform in a satisfactory manner. That is implied by the fact you followed all the rules. And frankly, beyond about 100 metres in height, it's pretty well extrapolation, because the codes and the systems and the rules were never envisaged for the sort of modern generation of ultra-high-rise building. And then the new school is performance-based or deformation-based. And here we're looking at setting meaningful performance targets which your clients can have a say in deciding what they are. We've got total design freedom, and I've got another stop this afternoon, and I'll just show you where that can lead us. There's no prescribed systems. You can do what you like, provided it works. And then you have to demonstrate in first principles that the design targets are met. And we look on an element-by-element basis rather than an overall system basis. But the common feature of the procedures as they're carried out in various parts of the world is that there is an expert peer review as part of this process. And in keeping with modern thought, we're moving away from the idea of seismic forces and moving towards the idea of seismic-induced deformations. And there's various good reasons why we should do this. And because working up from the bottom, ductility demands are related to deformation. Damage, non-structural damage, is related to deformation. And another thing very handy for us designing high-rise buildings, which have very long natural periods, is that in this long natural period range, and it's been known for a very long time, but actually the amount of deformation is not really very sensitive to how strong you make your structure. So the idea you provide force and gives you some safety, force or strength, is not necessarily the right way to be thinking of. Performance-based design is in practice in Japan and China, and it's mandatory for buildings exceeding certain height limits. There are no minimum strength limits, so there's no minimum base shear. There's no prescribed systems, but you have to assess damage by first principles, and you check things element by element, story by story, to make sure that your performance targets have been met. But it does require non-linear dynamic analysis, and people have tried to persuade me for years that static pushover is the answer to all our wishes and requirements, but it simply isn't the high-rise buildings where they are multi-mode structures, if you think of them in an elastic sense. So in Japan, it applies to all buildings over 60 metres. And there's a two-level check. The first level is an elastic check to make sure the structure essentially remains elastic, that is undamaged. And this is related to the important issue of economic loss. We're maybe not only concerned about life safety, but also economic loss and damage. And the second level is at twice the amount of shaking, and there is an interstory drift limit, and various ductility factors must not be exceeded. But there is peer review by an expert panel of 24 professors who give you a grilling, and it won't be approved unless they're fully satisfied that the building works. In China, it's very similar. Thinking about what we might end up producing, I think that what they've set in place in China actually is very sensible, because they have different seismic zones in China, and there are various limits they set based on the structural form and the cyclic zone. That seems quite sensible. They have 3 performance checks, which, if you want to look at the details, are there. But again, there's a peer review by expert panels. Again, it is largely professors who make sure that they're completely satisfied. And they've stopped things in the past. They say, I'm not satisfied by that, go away and do something else. This just shows the Chinese height limits for concrete structures, just showing that they've thought about what should be permitted, what shouldn't be permitted in their different seismic zones. So if we compare with what people are more familiar with, probably in most of the world, it's the UBC, IBC, Eurocode 8 is similar. It's a force, strength-based approach, looking just at life safety and force over 5-year return period, based on linear analysis, normally linear response spectrum analysis with ductility reduced excitation, based on prescribed overall structural systems. And there are detailed rules, no explicit assessment of what damage might occur. And I'll just remind you, it was never designed for very tall buildings. So what are the problems with it? Well, only a dual system is permitted. And if we look at this can be both uneconomic and architecturally restrictive. And also, it doesn't guarantee the building will perform very well. So altogether, that's not very helpful. You're permitted a very large force reduction factor, but an arbitrary, and it is entirely arbitrary, minimum base shear often governs. You don't have to check whether the building will collapse at a high level of shaking, and you're not required to check that the design you've made does actually perform to the actual required objective, which is life safety. And this is a bit of a problem, because we've been taking a look at some UBC designed buildings, assessing them by performance-based methods, and finding actually they don't perform very well at all. And we can look at how much deformation capacity is available by looking at the basic material properties of concrete and reinforcing steel, for example, for reinforced concrete buildings. And depending on how much, many of our structures these days are core structures, reinforced concrete core structures or shear wall structures, and in general, the cores or shear walls will take gravity load. I mean, a part of the vertical system as well. This is the economics of high-rise buildings. And basically, if you've got a very heavily loaded or significantly heavily loaded member in compression, the permissible ductility is about a tenth of what it is if you don't have that contractile load. So this actually is quite a problem, and people are applying the code without realising this. So here, this is a floor plan for building. Is this a dual system? It's got a concrete shear walls, it's got perimeter frames. Is it a dual system? Is R equals 8.5 appropriate? And this idea, well, small print on a dual system, which people don't often read, is that the lateral resisting element should not take much gravity load. They don't say how much, but that's the implication. But actually, if we're designing a building 200, 300 metres high, we don't really want some elements to have not much gravity stress on them and others to have a lot of gravity stress on them, because we end up with differential vertical shortening problems. So there's other risks which haven't really been thought through. Anyway, this actually isn't a dual system in the strict sense of the code, because the core is taking a lot of steel load. And if you look at this is the building. I won't talk about this building this afternoon in other contexts, but the minimum base shear is 5.5% to the code. It's got outriggers. Are outriggers allowed in the dual system? All these questions are not really covered in the old code. And what we found was that although the code says you've got to design for 5.5% base shear, actually you can show performs adequately. It's designed for 2.5% base shear, which actually is what the effective wind load was. And actually, if you had designed it even for the 5.5% base shear and done the design of the core in the way where you eventually do it, you reduce your forces by seismic forces by a factor of 8.5, you stuff your core full of compression reinforcement to take those reduced loads with the concrete, you find it has negligible ductility at the bottom of the core, which is one of the places where you need to supply significant plastic rotation. And so the code design wouldn't work, and yet here's a design which has got a lot less material in it, which works better than an unsafe code design. So this is good news, because we can do a better design more economically by using performance-based. What we're trying to do is produce a design guide. We're writing it right now. We want to look at best international experience. We want it to be relevant not only in high seismic zones, but in lower seismic zones. We want to draw attention to the inadequacy of commonly used procedures, to recommend more appropriate procedures, and in some countries, a UBC style code is the law. You have to comply. And so we feel that hopefully this guide will maybe use as a reference in support of change in those jurisdictions, because it needs to happen. To be wide-ranging, it's not just about structural engineering. And there are lots of issues to do with, when we move into time history analysis, for example, selecting ground motion. It's being written by these two people, myself, Klemencic and Willford, and we want to send it round to review, full review, by whoever would like to review it. So if you would like to review it, I'd be pleased to take your email address and we'll include you on the list. Thank you.
Okay, brief feedback on the CTBUH working group on the sustainable design of tall buildings. You'll notice that there is not a tall building represented in the title slide, which was a conscious decision. I want to start with this, which I think is representative of one of the biggest challenges facing the incorporation of true sustainable design in all buildings facing us today. It's greenwash. And what that means, in my book, is the lack of systems, I guess, to allow anybody to claim that their building is a sustainable building, the way forward, the answer, and then to not back that up afterwards. I think one of the biggest challenges with sustainable design is the lack of post-occupancy monitoring. And the second big challenge is, even where post-occupancy monitoring does occur, clients, developers and others involved are loath to release the information. And I think this is doing the profession really no service, in that it is very easy to say that our building is sustainable, reduces energy by blah blah blah, but unless we actually have the data to support that, then I think a lot of people will remain sceptical. And there have been moves, of course there have been moves in the past few years to counteract that by bodies such as LEED, the LEED rating system, BREEAM in the UK and others internationally. But I think these are voluntary bodies, and not everybody signs up to them. And I think that the profession, as a professional response, needs to start actually taking the issue of post-occupancy monitoring more seriously and being open. Where things don't work, a lot of these are experimental technologies, and where things don't work, there needs to be more of a spirit fostered of collaboration and dissemination of information so that everybody can learn from it. I think tall buildings are... Let me move off the green slide. I think tall buildings are really, and people involved in the creation of tall buildings are in a unique position. Tall buildings is such a massive undertaking and involves so much effort from so many cross-disciplinary professionals. They involve so much special research that goes into them, that they have this opportunity to really push forward systems of sustainable design. Whether that's technologies or sustainable design approaches at conceptual level, they have the opportunity to show the way, to lead the way, because there is an expenditure in them in terms of both finances and personal energy, professional energy, which is perhaps not replicated in smaller buildings through virtue of their size. So tall buildings really could be leading the way. I just want to run through quickly a draft agenda for what this group could be studying. I'm not going to dwell on the reasons why sustainability are important. I'm sure you should all know that, or I'm sure you do all know that, to do with climate change and other factors. But one of the things that we feel that the working group should address is the fact that there still remains a very sceptical public and professional body throughout the world who really feel that skyscrapers are not an appropriate part of our urban typologies at all. And that's also from an environmental viewpoint. There are people who make statements such as the one on the top of the screen just a couple of years ago. An experimental typology that has failed, that they are anti-environmental because of things like the embodied energies involved in getting them built in the first place. I'm not going to run through that list, you'll be very pleased to know. But there are a whole host of things that have been gathered to hurl at why tall buildings are anti-environmental. Of course, there's a case for why they are environmental or good, sustainable approaches. And this has to do with what I think is the bigger picture. And the bigger picture is to do with denser cities. It is to do with not an ever-encroaching suburbia on developing cities. And by developing cities, I mean these cities that are developing in places like China, India, and the developing world. I'm sure you've all seen figures like this before. I think we recently passed the point in the world where more than 50% live in urbanised centres. And obviously that is projected to grow massively. If you compare to, just 50 years ago, the number of massive urban centres above 1 million, above 10 million is growing. So the developing world And the relationship of tall buildings to cities is important. It's not just the developing world. In the UK, population demographics, even though our population in the UK is more or less static, it's not as static as they thought it was going to be because there's immigration from Eastern Europe, but it's more or less static. And yet, there is a requirement for 2.6 million new homes by 2020, even in a country like the UK. Now, why is that? Because of the population demographics, social demographics. People are living longer. There is more divorce. There are more single people homes. All these factors require homes. Where are these homes going to go? You know, a lot of people believe that they need to be provided in denser cities. I put this slide up not just to show that the UK and the USA are very good at energy consumption, or consumption full stop, but also to show that approximately somewhere between 30 and 40% of all energy usage is reckoned to be taken up by buildings, and a further 30-40% through transport. Now, buildings and transport, you know, that's cities. That's within our remit as professionals of what we can influence. That's the majority of energy usage. You know, the presentation yesterday on Songdo City, there are professionals amongst us, that are actually creating whole new cities. And that relationship between buildings and transport is vitally important. And again, one of my favourite graphs to show, to just reinforce, this is a graph of energy usage, if you like, against density. And you'll see that some of the most energy efficient cities are the denser cities, such as Hong Kong, Singapore, some of the European cities where public transport systems and things like this are perhaps more used. So the working group, I mean, I should just explain at this point that the working group, the Council Working Group on Sustainability, consists of just me. It is the newest one of the 4 working groups so far. So this is just some thoughts that I'm putting across, and the message I want to put out today is, you know, if you want to get involved in this, please contact me, because so these are just my ideas. But it's going to be looking at international case studies. International case studies that tout themselves, sorry, that's the wrong word, that have been hailed as sustainable tall building designs, of which I'm sure they all are, or many are. But you know, if they're so great, why can't we see the data? Why can't we use that data? Why isn't it monitored? Why can't we use the data to further the cause, so that this is going to be implemented more by clients and developers? Interestingly, another major challenge in tall buildings is that energy usage in itself is actually not much of a factor for most major corporations. You know, it might make up somewhere between 1 and 2% of their total expenditure when you compare to salaries and all the rest involved in running that operation. So if someone comes up to a client and says, well, I can cut your energy usage by 50%, obviously that's not as much of an incentive as cutting the salary bill by 50%. So that's also a challenge in getting a lot of professionals involved in the financing of tall buildings and buildings generally to take sustainability seriously. The response in Europe, through a European directive, is to start to insist that tall buildings have energy ratings. This happened in the electrical appliance industry in Europe 10 years ago, where if you buy a refrigerator now, it has an energy rating, somewhere between A and F. If you went to buy an electrical appliance 10 years ago, you would have seen the shelves of retail stores stocked with appliances ranging from A to F. You go now and there are no Fs. There are not even any Bs. Because people make choices not only on aesthetics and cost, but they make it on energy ratings. And the intention in Europe is to introduce that to buildings. Obviously that's a more complex thing, but this is through legislation. There are many people who think that a legislative approach would not work in America, but there must be other ways. So international case studies across the globe. Built and unbuilt. There's a lot of work being done in academia and other places which actually doesn't get to be built, but is of real worth in terms of what it brings to the party. Sustainability for me is not just about energy usage, it is about other things. For for want of a better term, sustainability of an internal environment. You know, as in all architecture, things are about compromise and trade-off. And we could make the most efficient, energy-efficient building, but it's also about quality of internal space. One of the debates in the UK at the moment is about transparency and how we should no longer be building glass towers through the new Part L and I won't go into that. But anyway, so some responses have been to insist on more opaque tall buildings. Actually, the work of Ken Shuttleworth, formerly of Foster, you'll see in the Kite Tower on the right. Ken is one of the main advocates for this, which actually I think could lead. Some of the most interesting projects we saw yesterday were not necessarily those that were just glass towers. However, that has a knock-on effect on the quality of internal space, light and other things. So this has to be considered in symbiosis. Social sustainability. This building is in the city where I come from, Manchester. It's the tallest residential tower. It's now built. It's now topped out and ready for occupancy soon. It's the tallest residential tower in England. And Manchester is used as a case study to show the resurgence of our city centres. In Britain, most people moved out of city centres to the suburb many years ago, and cities therefore are dead after 5, 6 o'clock in the evening. Look at those statistics. The population of the city centre of Manchester, this is a city of arguably somewhere in the region of 3 million people. The city centre in 1991 had 90 people living there. Now, by city centre, I mean the concentrated CBD, the central business district. It might be a couple of square miles, but 90 people. And that figure today is 15,000 people. So obviously, the policies of taller buildings and dense inner city developments has had a major impact on repopulating our city centres. However, these people are almost all exclusively from one socio-economic group. They're almost exclusively young professionals who are at that stage in their life where they want to live in the city. As soon as they get married and have kids, they move back out to the suburbs with, where they want a house and a garden. Because tall buildings around the world do not provide, generally speaking, for families. There is a lack of community, social, public space. I'm not going to go into this, but one of the projects that we did at my last university was looking how Commerzbank could be a model for actually a sustainable residential development. And these sky gardens that step up the tower could actually become communal gardens. To finish, an initial agenda. As I've said, there is an opportunity for tall buildings to lead the way in building sustainability because of the investment in them. I think this agenda needs to dispel the myths, dispel greenwash, to make a push for post-occupancy monitoring amongst clients and professionals. Who knows? Could we have a lead rating point for agreement for post-occupancy monitoring? Or could actually a requirement for lead rating be an agreement for post-occupancy monitoring? Controversial statements. An intention for the group is to examine best practice internationally. One of the things that the Council does very well with its international base and cross-disciplinary membership, but actually looking what is the criteria, what are the differences, what are the similarities across LEED, BRIAN, CASB and all the other international bodies, and trying to bring some sense of the different approaches there. Encapsulate the best case studies in the built and unbuilt realm. Obviously develop close links with similar organisations. And just to reiterate, for me, it's not just about energy usage. It's about urban sustainability, quality of internal space, social sustainability, and all the other factors. And if you're interested, please get involved.